Hi, we are the Kalimbros, and this is our final project proposal. My name is Caitlin Kreger.
My name is Macy Jameson.
My name is Ryan Sturdivant.
I am Sebastian Segol.
And I'm Shinobu Terona.
Our group decided to design a kalimba. So just a brief overview of kalimba history. It was designed and created about 3,000 years ago, and it was originally from Africa, although it's used in a lot of different cultures. Specifically, we found traces of it in African culture, Asian, Polynesian, and Native American cultures. And the main focus of this instrument across all of these different cultures is that it fosters unity and connection with the spiritual world.
Next, we have the kalimba build. It contains three main components: the body, tine, and mounting apparatus. The body is typically made out of wood, but it has been made out of other things in the past. The metal tines were introduced 700 years after the invention, and they were typically made out of steel. And then the mount is a combination of metal and wood. And then below just kind of combines all of the components that we talked about.
And regarding the engineering and sustainability issues, the main sustainability problem of the kalimba is that it's usually built out of very high quality wood that is sought after around the entire world. And due to this, it's usually counted as something that isn't really considered, a sustainable material for an instrument. So for our preliminary design focus, we wanted to kind of change and reduce the shape of or reduce the size of the kalimba in without changing too much of the sound quality. That way we can be using less amount of wood for the sake of, or preserving, other forests or whatsoever. In addition to this, we were also looking at other sustainable alternatives outside of wood because once again, for most instruments, wood is a very common material that's used. So later on, we'll explain that we've tried different materials, but for our primary design, our primary goal was to mostly figure out what type of wood we would want to use that would be, less, that would be more sustainable in addition to reducing the size of the overall kalimba.
For the alternatives or different solutions, we're looking for our project. So initially, we had two solutions. The first solution was to make a kalimba where like two people could play at the same time. So the reason behind this design was since the kalimba originally and traditionally has been an instrument that has allowed for the people around to bond with each other. Then we kind of wanted to take that intention into this design, and we made it so multiple people could play at the same time to kind of symbolize that bond. Our second solution it was to add a resonator to the kalimba. In that way, we could improve the sonic qualities of the instrument and the loudness of it as well. And at the same time, we could reduce the dependency for this very hard this limba wood that's endemic to Africa. That's very hard to get, and it's and yeah. So we're using metal for the resonator.
For the next slide, we did the testing and we used the kalimba and we placed it in either a plastic, metal, or a wooden bowl. And the plastic bowl made a dull and muted sound. The metal bowl produced a loud and piercing sound, and the wooden bowl produced a deep, warmer sound. And we ended up using the wood for our final design.
So in our initial prototyping, we started with kind of a solid slab of wood, which isn't typical for a kalimba. Usually you have a hollow one. So we wanted to focus on how the resonators would sound using the solid block of wood. And so kind of our initial problems that we identified were that the resonators were a little too stiff. They didn't actually amplify the sound enough because they were solid as well. and that's something that we address later on. And the tines were also too soft. When you pluck it, they didn't vibrate enough to kind of produce that loud sound. So it was kind of a twofold issue of the tines not producing enough sound and the resonators being too stiff to pick it up. And so we address this in our next revision.
And regarding the fixes and updates, we, redid the resonator. We included a little resonator spacer to this design, in addition to adding like a metal bridge. And we also shrunk the tines because we realized that each tine kind of took up too much space and there just wasn't enough wiggle room for, the instrument to properly vibrate. And we also used countersunk bolt holes in addition to adding a metal Z bracket to this design.
So for the final design, we had to implement all of those fixes and solutions. The first step was redesigning the resonator. What we did is separated the inside of the flat disc from the outside of the flat disc. So that way the outer could be mounted on the lip of the wood and the inner could still vibrate with the tines. We connected the two with thin metal bands between them. So that way it was less stiff than before, but we could still keep it in the small sizing that we wanted. Doing this let us keep our initial dimensions of 5 inches by 10 inches. And as another part of this, we had to fix the bridge. So we hand carved a piece of redwood to get the clearance for the board as well as the pocket for the metal rod to be installed as well. We also switched over the tines to a standard over the shelf kind of parts list, including a metal Z bracket, a little bit smaller tines, and also the metal rod itself to go into the bridge. Overall, these fixes led us to a good final design that both looked impressive and sounded very well. We were able to get good notes out of it, recognizable notes, and play them differently and get us much better sound than we expected. As we see, the final design got manufactured and worked fairly well. We also added some laser cutting services to it and got ourselves the team name and our professor on the back of it.
Thank you. Next, we'll be showing a video of the Kalimba actually working.